Hello, everyone. My name is Marcus Placona. I'm a developer evangelist for a company called Twilio. Just out of curiosity, who's not heard about Twilio before? Okay, great. So Twilio is a communications platform that helps developers like yourselves adding SMS messages, voice like telephone calls, messaging like chat, video, and push notifications into your applications, okay? So these are the applications you're already building using the languages you already know. Like it's a RESTful API, so it's pretty easy to get started, and it's got libraries for all of the kind of mainstream languages. But this is not what I'm here to talk about today. So how many of you are Android developers? Cool. And how many of you heard about Android things? How many of you did anything with Android things? Right, okay, so hopefully this talk is for you, because today you're going to see how to do some stuff with Android things. Like, you're going to see how to build your first application with Android things. And we're going to start really simple here. Like, we're going to start with a very simple application, and then we're going to try and get a bit more complex with the internet helping, of course, because this is the Internet of Things. So obviously we need to get the internet working. It's been working so far, so hopefully everything is going to be fine. In this screen here, you're going to find some information about me. So I'm Marcus_Placona on Twitter. So if you want to find me, that's the best place to find me. I'm also on GitHub, and I also run AndroidThings.rocks. So AndroidThings.rocks is basically all of my research about Android things. So everything I've been doing with Android things. There's a bunch of examples, a bunch of codes. But the most important thing is, in here, you will find all the codes for all the things I'm going to show you today, and some of the other things I've been doing. So this is the one you wanna keep in mind, okay? But let's just start for a minute, and let's just say let's just find out what Android things actually is, okay? Because Android things is an extension. It's an extension of the Android platform for IoT. Right? So I think some of you may have heard about, obviously, Android on mobile, because this is where it started. Then there's also Wear, which is like, what runs on your watch. There's TV, Android TV, right? And there's Auto, which I guess no one uses right now because it's not quite there yet. But Android things is a different thing, because the idea with Android things is you are now supposed to run Android things in things. Right? So as you can see, the idea with Android things is you can start running that on cameras, gateways, smart meters, points of sale. You can do security systems as well, and you can do stuff like asset tracking, fleet management. So there's a bunch of things you can do with it. And the beauty of Android things, which is like my favorite thing about it, is it runs on the technologies you already know. If you're an Android developer, then this is the technology you already know. It runs on the IDE you already know, Android Studio, which is the greatest IDE out there, in my opinion. But you can also do other things with this. Like, you can use Firebase, you can use Google Cloud, you can use Kotlin if you are into it. So basically, anything that you can do with Android, you can now do on a device. And we're gonna talk a little bit about devices as well, because I say you can run that on a bunch of things, but where does it actually run? Like, where can you run Android things? And a common mistake to people starting with it is they think they can run Android things on a phone, which is not the case. So the idea with Android things is you go away from the phone, and now you have hardware. Now you have different stuff. I am going to show you some hardware today as well. I'm going to show you some of the things that you can do with it. But I kind of wanna stop for a bit and tell you which hardware you can use right now. So some of the hardware you can use is obviously the Intel Edison, the Intel JAL, the NXP Pico, and my favorite of all, Raspberry Pis. Now, the reason the Raspberry Pi is my favorite of all is, if you look at the bottom here, you see prices. Okay? Not only the Raspberry Pi is only 35 euros when you compare to anything else like the Intel JAL, for example, which is 200 euros, or roughly that price, but also the Raspberry Pi has an amazing community, right? And I think the amazing community here is very important, because you are going to run into trouble. Like, there are going to be things that you don't know what they do, how they work, so you are going to run into trouble. And I found that the Raspberry Pi community is very helpful for that, because as soon as you get stuck with something, you just go and, go to the Raspberry Pi forum, ask your question, and someone is going to be able to help you out. Maybe they're not going to help you out with your Android code, but they will help you out with how the Raspberry Pi works. And there's also another reason why I prefer to use the Raspberry Pi, which is I'm okay with paying 35 euros to hide a Raspberry Pi behind my door. I'm not okay with paying like 200 euros to do that. Like, if I'm trying to do something like this, for example, this is like a doorbell kind of system where you can basically, like, there's a camera, so it sees the people outside. I'm okay with having this behind my door, okay? I'm okay with maybe smashing my door and breaking this thing and just going and buying a new Raspberry Pi. If I have a 200 euro device, I'm not too good with this. Like, I'm not too happy about, like, breaking that, okay? But that's just me. But how do you get started? Like, you can build stuff like this, which is really cool. You can do stuff like smart meters. You can do stuff like you can put that behind your switch or something, and you can now have like your lights blinking. You can control your lights and everything. But how do you get started? So what do you do to actually get started? It's very easy, because all you need is a Raspberry Pi. Everything else, if you're an Android developer, you've got everything else that you need, okay? So you're going to get a Raspberry Pi, then you're going to put a memory card on it, so you can put any memory cards on it, and you're going to use the IDE that you already use, so the IDE that you probably already have installed on your computer. And what's going to happen is, now, in that memory card, you're just going to burn the Android Things image to it. Now, there's one thing about burning the Android Things image to it. When you do that, you're going to wait for a while. And yes, that does take a while. That does take about 20 minutes. So what I usually tell people to do is go make some tea, go get some coffee, go out, get some fresh air, because that's going to take a while. Because you're basically creating your memory stick, like you're basically creating your image, which you downloaded from the Google website, from the Android Things website. And when you're done, you're going to be presented with a screen that looks like this. Okay? So now you have Android Things. You're going to start off with no Wi-Fi connection. The first time you install Android Things, you are going to have to connect an Ethernet cable. The reason you need to connect an Ethernet cable is you need to tell it what kind of Wi-Fi to use. There is a way you can actually boot it up with a Wi-Fi. It's really complicated, so my favorite way is just go, connect to an Ethernet cable, and be done with it. Then once it's on the Wi-Fi, it's so good. But don't take my words for it. Let's look at how we actually start building an Android Things application. So let's see what we need to do. And if for some reason this totally fails because the internet's not working, I have a video here so I can show you a video of what it's going to be like. I'm going to flick to my IDE here. And like I said, I'm running Android Studio here. You people in the back, can you see that? Is that okay? Is that big enough? Cool. So I am going to switch to my demo one, which, as you see, if you've done any Android development, you see that I don't want to have to create an application in front of you here, because like this is basically just an application. I just create a blank application. You don't need to say, I want to create an Android Things application. You start with a blank Android application, okay? So I have an application. I have my manifest here, which doesn't really have much, and I have an activity, which I called peripheral activity. It doesn't have anything on it. It doesn't do anything right now. If you try and run it, it's just the bog standard activity, just the bog standards, except for some comments in there. But it doesn't really have anything. The first thing you're going to do when you want to build your Android Things is when you want to add Android Things into your application, okay? Now, the one thing I need to make sure you understand is you can only run Android Things from Android version 7, NuGet or above, okay? Which is really not a problem, because like if I were here saying you can only run this Android application on an Android device from 7 and above, you'd be like, yeah, okay, so that serves me nothing because no one has 7 and above, like most people don't, okay? It's not a problem in here because you're running that on a device. So you're running that on a Raspberry Pi. So your Raspberry Pi is running Android Things, therefore it runs Android 7 or above. So you start off by adding Android things into your application. So I just added that provided Google Android things, and I'm going to add a version to it, which I am running 0.2 preview. So Android things right now is on 0.3 preview, okay? In all honesty, I was too scared to upgrade and break everything, because they only just released it like 2 weeks ago. So I was too scared to go and upgrade and then just come here and not be able to show you anything. But basically, adding Android things into your project is that, okay? So once you've done that, you're going to click sync, and Grado's going to go and download everything, okay? So once you finish syncing, you've got Android things on it. It's that easy, okay? Now, when you have Android things on it, the other thing you're going to have to do is you're going to change your filter. So we're going to create a new intent filter here, which basically tells your application that it needs to launch every single time you start up your Raspberry Pi. This is important because a Raspberry Pi itself doesn't have a screen. There's no way you can go and choose what you want to launch. So what you want to do here is you want to tell the Raspberry Pi that as soon as the application starts, as soon as the Raspberry Pi boots up, you want to launch that. Okay, so that's what it does. By the way, all this code is going to be on my GitHub account, so you don't need to try and copy or anything. It's going to be all there. So once you've done that, there's basically 3 steps. So we've done the first one, which is changing our Gradle file. We've done the second one, which is changing our manifest. And now we're going to go on the first sort of small demo here. We just want to see that we actually have access to our Raspberry Pi. Okay? So I'm going to create a new variable here, which is the peripheral manager service. I'm going to call that PM service. And I'm going to say new peripheral manager service. Okay? So that's basically me asking the Raspberry Pi, hey, can I get access to your GPIO? Can I get access to all your ports? I'm going to talk about the ports as well later. If it's something that you've not heard about, I am going to talk about those later. But basically, I'm saying that, okay? So now I want to know, okay, so how many ports are available to me? How many inputs and outputs are actually available to me? So let's log that. I'm going to call this GPIOs. And I'm going to do plus PM service dot get GPIO list. So hopefully what's going to happen in here is I'm asking for the peripheral manager service, and now I'm just trying to print what my inputs and outputs are. So Control R. This is hopefully going to try and deploy to my Raspberry Pi. You can see the thing at the bottom there. So Gradle builds is running. At some point, it's just going to go talk to my Raspberry Pi. Yeah, it's installing the APK, and you should see a log going back down there at the bottom there, which will show, yeah, okay. So that is what the GPIOs actually are. So those are the available ports, okay? So every time you want to do something like, maybe you want to blink a light, or maybe you want to control a button, or maybe you want to do something like, I don't know, have a GPS, for example, connected to it. You're going to have your GPS, you're going to have your peripherals, your external things connected to these, okay? It's going to be one of these ports. And you've got a bunch of them, okay? The beauty of the Raspberry Pi 3 is you actually have a bunch of things you can do with the same device, right? So it's not limited to ports. Like, I've done a bunch of things with it, and I've never run out of ports. But cool. So this is like how you actually make sure that you're running. Like, we're making sure that we're running this thing. So let's carry on. Let's go back to the slides for a bit. And I am going to skip my backup because this thing worked, so I don't need to show you this video. But what have we done so far? Like, we only connected to Android things. We haven't really done anything. Like, we've not, like, the beauty of Android things is the limitations you have on a phone where you can only run things on the hardware that is actually provided by that phone. This goes away now, okay? Because now you can run stuff on hardware. You can run stuff on different things. And I mentioned things like buttons, LEDs, GPS, for example, like GPS modules. But let's look at hardware. Is anyone here a hardware hacker? Like anyone actually plays with hardware? Okay, so some people do. Cool. Okay, so for the people who don't know, the people who haven't played with hardware before, let's just do a quick hardware 101. Let's just think about what kind of things we can do. And I'm going to go really simple here because this is what the Raspberry Pi 3 actually looks like. Okay, so you have a bunch of USB ports in there. You have an Ethernet connection. You have an HDMI port. You can connect to screen. So you have a bunch of things you can do with it. And these are all the general purpose input and output things you get from the Raspberry Pi 3, okay? So these are all the ports, like, BCM6, BCM5. So these are all the things you can connect to, okay? You have ground, you have power up there, so if you need power, you have a 3.3 volts and a 5 volts, which is what most of the hardware stuff that you connect to is going to need. It's either going to be a 5 volt or a 3.3 volt. And you've got both on the Raspberry Pi, which in my opinion is really helpful because you don't need to get an external source. Now, is this, I presume, like if you've done some hardware hackers, some of those things are going to be familiar to you. Some maybe not. So breadboards, for example, they are a construction base. So the idea with the breadboards is like when you're building something, when you're doing some hardware hacking, you don't want to go and print your own like PCB. Like you don't want to go and create your own printed circuit board, because that's going to take you some time, and you don't know if that's going to work. So the idea with a breadboard, it's like Lego. So you start with that, and from there, you just go to like adding extra things. So if you want to add LEDs, for example, like this one, resistors, jumper wires, you can do those things really quickly, which is pretty cool. You also have jumper wires. Okay, so jumper wires are basically a way for you to go like, oh, I want to connect from here to here. You use jumper wires for that. You're going to see those a lot, especially when you look at the Android things demos. You're going to see those things a lot. Like you're going to see jumper wires a lot. You're going to see some here today. You have resistors. So resistors are basically a way to help you reduce the flow of current, right? So if you have something that needs 1 volt and 20 amps to run, like an LED, for example, then you're going to want to use one of those, okay? And the one important thing to know here is if you're not a hardware hacker, the colors actually matter, okay? Don't just go for the ones you think are like, oh, this looks nice, I'm going to use that. The colors actually matter, okay? Learning these colors is an absolute pain. Some people can look at a resistor and say, oh, yeah, this is like a 22 ohm resistor. I can't do that. So what I do is I just go to a website and I say, cool, I've got this LED. It's 1.1 volts, 20 milliamps. What kind of resistor do I need to use? And basically with that, I can say, right, I am going to plug my LED to the 5 volt line. And I know I'm not going to burn it. It is going to burn, okay? There's going to be, like, if you connect your LED to the 5 volt directly, there's going to be some smoke. There's going to be, like, it's going to smell weird. So it's the one thing to keep in mind, okay? So resistors are actually important. And then you have your LEDs, right? With LEDs, it's the same thing. You have an anode and you have a cathode. So those are basically the polarities. So you have positive and you have negative here. You have ground here. So obviously, you want to make sure that, they're like batteries. You want to make sure that you connect them in the right order, because otherwise, if you invert them, you're going to see that same weird smoke and the same weird smell. The thing about LEDs is they basically make things bright and shiny. And I really like playing with LEDs because it's the quickest way I can actually see some feedback. When I do anything, I can actually see some feedback because it's blinking. So it looks good, and I'm always happy when I see that. One of the other things you're also going to see, you're going to see people using this tool here called fritzing. And fritzing is great because what you can do with it is you can create these kind of mockups in here, okay? So you're not really running anything on it, but if I want to show you how my circuit actually looks like, I can draw something like this, and I can show it to you. And it's so much easier to go with that than like me taking a picture that is slightly blurred, and you're not going to be able to see my wires. So I can actually represent things with fritzing. Fritzing is a free tool. You can just go download it, and it's great, okay? So you will find that most people doing Android things, they are using fritzing right now because it's the same thing Google is using. And I just showed you this circuit, okay? Now, the one thing you're going to notice is this circuit actually has some external things. So there's like a resistor right here. There's a button here. And so what can we do with a circuit like this? So let's go on another demo to see if we can, if I can show you that kind of circuit. What you should see here, and I know this is running off my camera. You should be able to see that I have a circuit here that is very similar to the circuits I was showing you on the previous screen. So what this has is it's got, I think it looks okay. So it's got 3 wires to it. So it's got one blue wire, which is your ground. It's got a red wire that is connected to the 5 volts. And it's also got the purple-ish wire, which is connected to a button in there. Okay, so the blue thing down there is actually a button. Okay, you can come down and see these later if you wanna have a look at what this is. But this is like a really simple circuit. And what I wanna do is now I wanna come out of the software. So I wanna come out of having an application that has a button inside the application, and I wanna go out to the hardware. So I wanna go out and control my application from the external hardware. The way we do that is I'm going to go back into my code, and the one thing you're going to find about Android things is everything is a library. Everything is an external library. So you're not just downloading Android things and having this bloated thing inside your APK. You're actually downloading Android things as a standalone thing that only gives you access to the peripheral stuff. And then you have libraries for other things. So you have libraries for sensors. You have libraries for buttons. So we're going to look at a library for a button right now. And I'm going to show you some libraries later as well. So I'm going to go and also stick to 0.2 here. This is going to ask me to sync. And basically, once that's completed, I have the button library. So I'm not getting everything. I'm not getting the GPS stuff I told you about. I'm not bloating my application. I'm making sure that my applications are really lean and they only have what I need. This is going to make, this is going to make them more performant. And let's go back to my code. So in my code, what I'm going to do is I'm going to create a member variable at the top here. So now that's the important part. You will see that you have 2 options for button right now. So the first option is the widget, which is the button you can have inside your Android application. So if you're an Android developer, chances are you have used this before. The second one is the one we're interested in. So this is the Android things button. And as you can see, it says android.things.contrib. These are actually contributions from, this is all open source. So these are actually contributions from community members that actually go ahead and make changes to this, or they create new versions of it, they add new features to it, which is something I really like about Android things. It's all open source and it's all community driven. Now, great, so we're gonna add a button. Let's call this M button. And in here, we're gonna create a new button. So M button equals new button. And right, so new button, we need to pass 2 things to it, as you can see. So we have a pin, which is basically the GPIO pin that we want to use. And we have the logic state level. And we're going to look at that. So the pin I'm using is BCM6. And we're going to go to the logic state. And you have 2 logic states for a button. You have a logic state for when high. Okay, so if you press the button and you go back, you can trigger something. Or if you press the button, you can trigger something else. So let's look at low. Does that make sense? Like the logic state on the button? Like, press it, then it's low. Release it, then it's high. And that's gonna want to add some try-catch for us. Okay, so we have access to a button now, right? So we have a button. But what can we do with this button? Like, what kind of things we can do? So again, because this is Android, we are going to be using event listeners here. So let's go mbutton dot set on button event listener. So this is listening to a button now, and we're going to do new button event listener. So on button event, so anything that happens with the button, like if it's pressed, if it's released, we want to do something. I am just going to take this out from here. So now when the application starts, instead of showing information about the GPIOs straight away, I just want to show when I press the button. And this is going to ask me to make the variable final, which I'm going to do now. Great. OK, so now I have access to this button. I know when it's pressed, and when it's pressed, I'm going to show something on the screen. The last thing I want to do here, I want to make sure that if the application is destroyed, like when the application comes out of context, I want to make sure I close this button so I don't leave it hanging in there. So I just need to check that end button, not no. I want to do end button dot close, and this is also going to ask me for a try catch. Cool. Okay, so I am going to run this application again, and I'm going to quickly switch to the webcam. And as soon as this is completed, so it's building. Cool, so now it's installing the APK. It's funny, the thing about installing APKs, because it can take anything from like 1 second to like a life. Cool, so now it's installed, okay? So as you can see, you don't see anything at the bottom, like you can't see any logs at the bottom, because I haven't pushed the button. So I'm gonna try and push the button, and you will see my finger here. And if you look at the bottom, you see that something happens when I press the button. Okay, so now I'm controlling this button, like now I'm in control of this, okay? That wasn't too hard, was it? Like, I feel like that was a pretty simple thing to do. Thank you. Great. Let me start these again. And yes, I showed you a demo of this thing. Again, I have a video in case it didn't work. You'd be able to see that, but it's basically what I did just there. Maybe you can see the button better from this one. But the idea is like, now I have a button, I can go and trigger things. Like I can go and turn off lights, for example. This is connected to the Wi-Fi, okay? This could be connected to the Wi-Fi inside your house. You could do stuff like control your Philips Hue lamps, for example, from this. You can do those kind of things. Now, this is so good. Like, this is so great. But this is the part where people actually sometimes get confused about. Because some of the Android things, like some parts of the Android things are actually managed by Google, and some parts are actually managed by the community. And when I say the community, obviously Google, they are adding things to it themselves, but the community has access to everything. They can go and change things. So when you look at the peripheral manager service, for example, so that's the first thing we use in our code. This is a copy of the code I just wrote. So when you're looking at peripheral manager service, for example, this is managed by Google, right? There's no reason for you to say, I want to extend the GPIO, for example, because it's what's in there. But when you look at anything, any library that has contrib on it, those are libraries that have been contributed by either Google or community members, okay? Maybe Google will go and create this library, and community members will go and change it or add new functionality. Like, on version 0.1, I think, or no, maybe before that, the button library only had the low state. So there wasn't a concept of what happens when I release the button. That didn't exist. So community members went and said, cool, I want to do something when the button is actually released. So they just went and update the library. They just went and changed the library. So it's that easy to do. When it comes to libraries, what kind of libraries we have? We have some libraries, not many. But the one thing I like about these libraries is all of them, or most of them, are actually contributed by community members. So you have stuff like servo motors, for example. You have speakers and buzzers. There's a GPS up here. You have stuff like capacitive touch buttons, where like you touch a button and it does something. and this is all like capacitive, alphanumeric, and the beauty of it is people just keep on creating things. Like you find a hardware that you don't have access to, you find something, you find a piece of hardware that there's no library for it, what you can do is you can just create one. You create one, you make a pull request, and now your library is actually available for everyone to use, okay? And this is, I think this is pretty powerful because people have been building libraries for Android development for a while now. And those libraries, there's like, I can maybe think of 5 ways you can do an HTTP request with Android. So people just keep on like building things on top of things. Whereas the idea with this is, if there's no library for a certain hardware, I can just go and create it. And I can just contribute, I can write a blog post, and I can, I now have the bragging rights of saying, I've created this library, which I think is pretty cool. Like, so there's a bunch of people doing it. This is Xavi. So Xavi is like he's a big contributor on the Android Things project. He doesn't work for Google. He works for a different company, but he does like writing libraries and doing things. And in here, he's actually showing you how to write your first library. So he found a piece of hardware that wasn't supported, and he wrote something, which I think is kind of cool. Now, I said managed by Google, right? So what exactly is, so this is the Android. So this is like the whole Android ecosystem, okay? Like everything with Android that you're gonna do right now, today, you're gonna have access to all this stuff here. So some of it is on the Linux kernel, then you have libraries, you have your application framework, and then you have applications. The one thing to keep in mind is that because we're dealing with a hardware that doesn't necessarily have all the capabilities as a phone, there are going to be things that you're not going to have on Android Things. So you don't have access to things like messaging, for example, or contacts or calendars, because those things don't exist. Like when you set up a new phone, when you set up a new Android phone, you get all these things on the phone. When you set up a Raspberry Pi, those things don't exist. Like the Raspberry Pi is not a phone, and it's not meant to be a phone. So you don't have stuff like, runtime permissions, keyboards, for example. You don't have that. You can attach your own keyboards if you want, but it doesn't come with like, soft keyboards and wallpapers or anything. It's very bare, so it's very simple, and it's powerful, but it's very simple. It doesn't have all the things a phone has, which in my opinion is a good thing, because it makes you want to go and build the things yourself. The one thing about Android Things is displays are optional. So up until now, we haven't really looked at displays. Like, we haven't really used the display. Like, I'm kind of running this thing here. I'm looking at what the outputs are. I'm looking at the hardware, but displays are actually optional. You don't need to have a display. And what Google actually says is, you shouldn't have to use a display. You shouldn't have to have a display in order to give users a kind of a good experience. So you can do things like use microphones. You can do joysticks, for example. So there's certain things you can use that you don't necessarily need a display, okay? Because you have all the hardware, you have all the stuff on the sides that you can use. But how about we look at using this thing with a display? And this is when I'm going to have to move the camera now and might mess everything up. So I have a display connected to my Raspberry Pi here. And as you can see, if I go and, I don't know, let's just try and uninstall this application here. So let's see what applications we have first. So I've got 2 applications installed on this. And as you can see, like all the stuff I'm doing here is the same kind of stuff you would be doing with, should I make this bigger? Is the same kind of stuff you would be doing with an Android application, okay? So I can go adb uninstall and delete the application. And as you can see, the screen here just kind of switched to something else. So this is like the default screen on Android Things. And if I go ahead and deploy something to it again, you should see that in a bit. my screen is going to go back to the application. Yeah, so it launches the activity, okay? So if you want to have a screen and you can't see, this says hello world in the middle, so it's not important. But the one thing about this is you don't necessarily need the screen. But if you want to have a screen, if you want to build like management for your house, for example, if you want to do something like that, yes, you can have screens on it. You can have screens, you can have sensors, you basically can go both ways here. Like you can have buttons on your screen. This is touch screen as well, so you can like press buttons on it, but you can also have external buttons. Oh yeah, there's another thing I want to show you because this is something most people don't know. Do people know Visor here? Yeah, so Visor is this thing that is, it basically helps you see what's running on your screen, on your device's screen. So the device that is connected to your computer, you can see it. So even if you don't have a screen, you can just go and launch Visor, and it works. It works with your Android Things application as well. Eventually, like when it finishes loading, it works with your application. Yeah. Okay. So now you can see that it says "Hello World." It looks kind of crappy, but you get the idea, right? And from here, you've got stuff like you can use the back button, then you can go out of the application. So this is more of a tip than anything else, because when I started doing Android Things, I was like, yeah, that's great. Like, I know it's loading stuff, but if I want to have something that shows on the screen, how do I see that? And buying one of those screens is one option, okay? Like the screen is kind of plug and play, like you connect to the Raspberry Pi and that's it. But those screens they're not very cheap, and you may not need them. Whereas like when you can use something like Visor, for example, if you want to see what's going on the screen, then use Visor for that. Cool. So I just said that, yeah, no screens, no problem. So if you don't have a screen, if you don't have something that you can actually attach, you can use stuff like Visor, for example, and then it's going to end up being something like this. But I want to show you a different demo, and I want to tell you a story as well, because like I got really excited about Android Things. Okay, like I was like, yeah, I want to have this everywhere. Like I'm just gonna go and have this thing everywhere, and I decided to build a doorbell. So here's the backstory about the doorbell. I work from home and I keep listening to music. Like I'm always listening to my own music. And when the mailman comes to my house and presses the doorbell, I obviously never hear it because I've got my headphones on. Okay, so yeah, first world problems, right? So I obviously don't hear those things. But the one thing I always hear, because like it's literally in front of me, is I always hear my phone. Like my phone is in front of me, so if it vibrates or if it rings, I hear that. And then I was thinking, okay, so could I make my doorbell ring my phone? Is that something I could do? And sure enough, it's something I can do. And I went all crazy. I bought a massive button, like one of those arcade buttons, and I'm like, I'm gonna put this thing outside. When the mailman comes over, they're gonna push this button, it's gonna ring my phone, and it's gonna be amazing. So the one thing I found is like, if you have a massive red button in front of your house, people are gonna be too scared of pressing it. Okay, so go for a small button like the one I showed. Because if you have one of those big buttons, people will be scared. They'll be like, what's gonna happen when I push this? So they won't. But let's try and look at this application I built. And this one I built using some, so I'm going to show you some of my, I'm not a JavaScript developer, okay, so bear with me here. I basically just built a really simple Express application that does a few things. So, can you see it from the back, or should I try and make it bigger? Yeah, okay, cool. So the idea with this application is, I want my phone to ring whenever someone presses a button on my front door, okay? A small button, not a big button, remember this. And so and basically that's it. Like I just want my phone to ring when someone presses that button. So what I did was I went to And maybe I'll show you like a Riga example. So I'm gonna go ahead and get a telephone number in here. Okay, so I'm on the Twilio dashboard, and I'm gonna buy a telephone number, and I want it to be from Riga. Okay, because like we're in Riga now, so why not? And I'll go and buy this number. And what I'm gonna do is, so yeah, I just bought this number now. What I'm gonna do is I'm gonna change the number in here. So whenever someone presses the button, my Android application is gonna make an HTTP request to my server, which is this thing running here. And when it makes the HTTP request, it's gonna make my phone ring. And hopefully that's gonna work. Let's look at the code for this. Like, I didn't think I should actually go and write all this code in front of you. But you can see it's my code. It is running on ngrok, so it's running on my local machine. Okay, so I'm just going to copy my ngrok URL here. Is everyone familiar with ngrok? Cool. ngrok is awesome. The idea with ngrok is you have an application running on your local server, on your 127.0.0.1, and now you can actually tunnel from outside. You can tunnel from the internet to ngrok, which basically means now people from outside have access to my local machine. You're not going to give this to like everyone, but if you want someone to really like test something that you're building locally, that's a great way of doing it. So ngrok. And what I'm doing here is, again, I'm setting up my pin. I'm saying BCM6, which is the same pin I'm using for the button down here. And I'm saying, what's my base URL? And everything else, so this is what's cool about this. Everything else is the kind of stuff that you used to as an Android developer. I'm using, let's go to my, so I've got my interface here for retrofit. Make this bigger. Yeah, I've got my interface here for retrofit. It calls the /call in my application. And I have retrofit, so I'm just like initializing retrofit, and I'm initializing the doorbell button, okay? What needs to happen, and obviously I'm listening to the button, like when it's pressed. So if someone pressed the button, I just want to make an HTTP request, and I want to start a call. And hopefully with that, my phone should ring. So remember, the phone is going to be in front of me, and hopefully with that, it's going to ring. I am gonna install this thing to the Raspberry Pi. Do it. We should see that. As soon as it installs, it launches the activity. So the activity doesn't have anything. Okay, so remember, I'm using an external button to control this thing. And this is when I'm going to try and maybe move my phone to the top here. And I'm going to press a button. And you can't see my button, can you? So let's, okay. Yeah, I think that's good enough. I'm going to go and press the button. Something hopefully is going to happen, and my phone is going to ring if I did press the button correctly, which I think I did. Let's, yeah, so my phone is ringing right now. So I'm going to accept it, and I'm going to put it on speaker.
Someone at the door.
Did you hear that? So it's really simple. It just says there's someone at the door. But it's really cool because now there's this phone number which I can call doorbell. Okay, so I can add it to my contacts, call it doorbell. And now there's this phone number that calls me every single time someone rings a bell. And you know, sometimes I'm not going to be at home. But at least I know. At least I know someone went and rang my doorbell for some reason, okay? And I can do other things as well because, like, remember, I have a bunch of GPIO on this thing. So I can do things like I can have a camera on it. I can actually attach a camera to it. And when someone rings the button, I want to take a picture of that person. And that could be creepy, I know. But yeah, well, you can do whatever you want to do. So that could be creepy. But hey, now I know that the mailman came and rung my bell at 10 in the morning and I can do something about it. Like I can, I can maybe phone my neighbor real quickly and say, oh, better yet, I can actually make this thing phone my neighbor instead. Like pick up my parcel. So you can do those things, okay? Because now you're coming out of this whole idea of, like, I have a phone that is great in my pocket and it doesn't do much outside of it. And now you have the same power, you have the same potential to add those things into your house, into your whatever, like into your job and wherever you want. Now, with that, I want to say Android Things, it's got the power of Android. So all the things you can do with Android, you can do with Android Things. It's managed by Google, which makes it secure. Like one big problem with IoT is security. By the way, I have another talk about security later today. It's not on IoT, but it's about, I don't think anyone can talk about security in IoT because it doesn't exist, right? It's managed by Google and it's automatic and secure. With that, I've been Marcus Placona. All my information is here. If you want to harass me about my talk, say it was good, it was bad, let me know. Thank you very much. And I think we have maybe 3 minutes for questions. Does anyone want to ask any questions?
Yeah, just
Hello.
Hi.
Would you typically develop Android Things apps connected via Wi-Fi to your Raspberry, which is like at the door you attached already?
If it's at the door, yes. As you can see, today I'm not connected to the Wi-Fi. I'm connected to an Ethernet cable because I was too scared about relying on the Wi-Fi. But usually when I do it from home, for example, the cool thing about it is I can make changes to it all over Wi-Fi. Which is like, I don't need to like take anything apart. I can just make changes to the Wi-Fi. I can just make changes through Wi-Fi, which is super cool.
Hello, thank you for your talk. I wanted to ask if Android Things have access for all Raspberry Pi stuff. For example, can I react to the touch screen? Do I have access to the camera, like low profile stuff like?
Yeah, so for touchscreen, for example, yeah, absolutely, camera the same. So I actually have a Raspberry Pi camera, like the ones you can get from, I don't know, from the Raspberry Pi website. And yeah, you got access to everything. So you get access to everything you get from the Raspberry Pi. Maybe, I don't know, like I don't know how low level you can go on the Raspberry Pi. But all the stuff like cameras, for example, all the stuff like touchscreen and everything, you get access to everything, which is pretty cool. Like the camera is pretty cool. Like I was surprised by how easy it was to connect the camera because I was basically writing Android codes I use to get access to the phone's camera, but I was getting access to the Raspberry Pi camera.
Hi, question regarding probably is Android of Things be made from regular tablets, cheap tablets from China, or only compatible with Pi and?
Yeah, you won't be able to run that on a... So the two limitations of Android Things is, yes, you won't be able to run that on something that isn't one of the devices I showed before. And the second limitation is you can't run it on an emulator. So you need to have and I think that's going to change, okay? Because like what I showed you today is the 0.2 developer preview. So it's really early stages. I feel like the emulator side of it is going to change. Like at some point you should be able to do stuff on the emulator, but they will need to change the emulator for it because like the emulator has no concept of like peripherals and stuff. Like you almost need to have a Raspberry Pi emulator as opposed to just an Android emulator.
Marcos, maybe a more hardware question.
Yep.
Do you have an external power supply for your touchscreen, and how powerful is it?
So my touchscreen is connected to this power supply here. Okay, so this is like a
Power
phone.
bank.
Yeah, this is a power bank. Yeah.
Okay.
You can use your computer's USB as well. It will power it because it's really low power. It doesn't require a lot of power. So you can use something else as
For
well.
example, how long you can run your this touch screen with this power bank?
With that, so this is a pretty powerful power bank. It's like a
10,000.
10,000. With that, I've run it for like, well, I didn't run it until like it totally drains the whole thing. I'm also running on the lowest power. Like I have two power settings on this,
Yeah.
like a high one and a low one. I'm running on the lowest power, and I've run this thing for 9 days until I turned it off, and it was running fine. So I don't think it's something that is very, as in like, I wouldn't have this thing attached to a wall with the power bank, for example. I would probably have an external power supply, like a mains power supply for it. I wouldn't just use a power bank. I'm using the power bank here because it's easier on the setup, but I wouldn't use the power bank for the screen like forever.
It's one of problems to solve anyway.
Yeah.
Yeah, one question slightly related to the previous one. So, is there a basic part of the platform is it open source in the same way as AOSP is for Android?
Yes. Yeah, it is open source in the same way AOSP is open source for Android, I think.
So, is there any community of the companies developing AAT as a platform for their hardware?
I don't think so. So if there is, I don't know of any companies or communities building for it yet. But I think it's pretty hard right now because it's like developer preview. And maybe there will be communities building on top of it, but they're just not saying anything. Because it's developer preview still. It's changing quite a lot. Like it's changing quite a lot. On 0.3, we just got access to USB host, which we didn't have before. So now you can actually use it as a USB host. So it's changing quite a lot. So I don't think there's anyone actually firmly. I don't think there's anyone professionally building Android things applications right now. Everything I see is very much like, oh yeah, look, I can make this LED blink and I can like change my lights. But there's nothing. I don't think there's anyone professionally building stuff with it yet, or at least they're not advertising it. One question there.
Hi.
Hey.
Have you tried to build a driver for Android things? And like, what
Yeah.
programming language do you use for building the drivers?
Yeah, Java. So you can. The drivers are basically libraries that you build. So you can go low level as well. Okay, so you can build drivers using the NDK, right? So you can do C, C++. I've built. There's a limitation with Android things that maybe I didn't mention here, and it might not be very important, but it was important to me. Because the Raspberry Pi runs Linux, Linux is not meant to be real time, okay? So when you're talking about microseconds, Linux doesn't do microseconds. You can do milliseconds with Linux. You can say like, I wanna send a pulse request every 5,000 milliseconds, for example, every 5,000 milliseconds. But you can't do like, I wanna send a pulse request for every 10 microseconds. And where this actually gets, where this is actually important is, some hardware actually needs requests every X microseconds. And this thing doesn't do it. Like, it's not a limitation to Android things, it's a limitation to Linux. So what you can do is, you can connect an Arduino to it, because Arduinos can do microseconds. And now you're basically having the Arduino communicate with the Raspberry Pi, either via serial or via USB. And it also works. And I actually built a driver for this. So I built a driver to help you connecting your Raspberry Pi to an Arduino. The beauty of it is, anything that runs in the Arduino can now send information to your Raspberry Pi. So any libraries that you know that you can use on the Arduino now can send information to the Raspberry Pi. So, but yeah, I built my whole thing in Java, like all Android.
Yeah, that was last question because we are running out of time.
Thank you very much.
Now will be lunch in room 7. Yeah, and thank you for the speech.
Oh yeah, can I just say one last thing? I've got some Android Things stickers here. If you want an Android Things sticker, if you want to see what kind of rig I have here, just come down here and have a look.
One more thing, you can find the speaker if you have more questions on the 6th floor where there is speaker room. and you can ask other questions.
I didn't know there was a speaker room, but I'll be around
Now you know.
today and tomorrow. Thank you.